And
Allumage
liftoff.
UAP, décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself.
NASA scientists are one step closer to unlocking the secrets of the universe.
The JWST is performing better than the specifications. We're seeing not only things in the foreground, but all of these background galaxies.
The time for Halloween must be nearing. Space agencies like NASA and ESA are beginning to embrace the spooky aspects of space, as astounding new images from the James Webb Space Telescope have shown the gaseous bone structure of a faraway galaxy. This new perspective from the James Webb Space Telescope shows the center of a spiral galaxy, and it looks like the skeleton of a whirlpool. What exactly is it about this galaxy that is so astounding? And what other galaxies has the JWST observed so far? Join along as we dig into the wonders of the cosmos and discuss this skeleton-like galaxy which has shocked everyone. Astronomers typically see a fuzzy, hazy, spiral-shaped structure when they look at the galaxy known as IC 5332, making it difficult to make out fine details. But when the James Webb Space Telescope turned its cutting-edge instruments onto the galaxy, it gave researchers an unprecedented glimpse into the intricate structure of this galaxy, as reported by the European Space Agency, ESA. The highly detailed image of IC 5332, which is more than 29 million light-years from Earth, is just the latest in a series of amazing photos obtained by Webb, the $10 billion telescope that was launched last December. At a diameter of about 66,000 light-years, IC 5332 is about 2/3 as large as our own Milky Way. Its orientation toward Earth provides astronomers with an uninterrupted glimpse of the spiral arms of the galaxy. Webb's mid-infrared instrument, MIRI, detected IC 5332's signature at wavelengths between 5 and 28 microns, which are outside the range of human vision. This powerful instrument has specific temperature needs in order to function properly. It requires an operating temperature of just 7 degrees Celsius above absolute zero, or minus 266 degrees Celsius, minus 447 degrees Fahrenheit. Engineers built an active cooling system specifically for MIRI so that it would always be at the ideal temperature. It is essential that MIRI be supercooled to eliminate noise from other infrared radiation that could result in blurry images. Webb as a whole is kept cool, but not as cool as MIRI, which is kept at a temperature 33 degrees Celsius below that of the rest of the observatory. According to ESA, the extra effort made to ensure MIRI's detectors had the freezing environment necessary to operate properly is evident in this stunning image. Using its Wide Field Camera 3, the Hubble Space Telescope captured an image of the same galaxy. When comparing the photos of the two telescopes, it's easy to see the differences. Hubble's ultraviolet and visible light images show the various colors of younger and older stars, as well as dark areas of cosmic dust. Webb, on the other hand, was able to see through the dust to the patterns of gas strewn throughout the galaxy, which reveal a continual tangle of structures that echo the spiral arm's shape, according to ESA. According to NASA, Webb's image is dark and moody and depicts the bones of the galaxy. "Space, but make it goth," tweeted the agency. Since different wavelengths, ultraviolet, visible light, and infrared, make distinct stars look brighter, the two photos also reveal different stars. The images complement one another in a remarkable way, each telling us more about IC 5332's structure and composition. The Hubble image shows dark regions that seem to separate the spiral arms, whereas the Webb image shows more of a continual tangle of structures that echo the spiral arm's shape, said the representatives of the European Space Agency. According to the European Space Agency, the discrepancy arises because the dust in the galaxy is more effective at scattering ultraviolet and visible light, which Hubble detects, than the infrared frequencies accessible to the JWST. To better understand the composition and structure of IC 5332 and how it relates to common features of spiral galaxies, ESA scientists are comparing images of the galaxy taken by Hubble and the James Webb Space Telescope. The telescope has captured stunning images of cartwheel galaxies, Einstein rings, Orion's sword, Neptune's ghostly halo, and the deepest image of the universe ever produced, to name a few. Hubble sometimes gets a poor press for being outclassed by the brand new James Webb Space Telescope. It is not, however, inferior. Rather, they are designed to view the cosmos in different ways. So what other images has the JWST returned so far? The James Webb Space Telescope continues to send stunning images of the universe, demonstrating that years of development and delays are worth the wait. Astrophotographer Judy Schmidt recently processed a JWST image of the spiral galaxy NGC 1365 that features a double bar. The galaxy is found in the southern constellation Fornax at a distance of about 56 million light-years from Earth. Schmidt explains that the data used in her image processing came from the FANGS group, which studies physics at high angular resolution in nearby galaxies. NGC 1365 is more than twice as huge as the Milky Way, with a diameter of almost 200,000 light-years. The unique curving shape of the galaxy, which resembles the Latin letter Z, is due to the way its wide arms reach away from the central band. Because of its peculiar shape and the fact that much of its internal structure is obscured by dust, James Webb was chosen for observations on this galaxy. The infrared observing capabilities of JWST allowed it to investigate the galaxy in ways that Hubble and VLT were unable to. NGC 1365, like many spiral star systems, features a bar. This is the name of the structure made up of stars and interstellar gas that crosses the galactic core. However, unlike other identical objects, this galaxy has an important feature. Two bars, one huge and one small, travel through its core at the same time. The image was captured by the James Webb MIRI mid-infrared sensor and sheds fresh light on the galaxy's interior structure. The new image features a detailed overview of the central area as well as numerous smaller, thin sleeves spreading from it. An active halo-shaped star formation zone is evident in the center, with luminous dust surrounding it. NGC 1365 and other spiral galaxies with bars are of great interest to astronomers due to new observations that have shown that the Milky Way may be a spiral galaxy with a bar. About 75% of all galaxies in the universe are thought to be spirals, and studying them can tell us a lot about how our own galaxy was formed and how it evolved. JWST's sophisticated infrared optics make it ideal for investigating galactic nuclei to better understand the mechanisms behind star formation, supermassive black holes, relativistic jets, and more. James Webb will use its powerful mirrors to examine regions of the universe that are normally inaccessible to astronomy in visible light, such as regions of star formation, protoplanetary disks from which planets emerge, and the centers of active galaxies. The telescope will also focus on the galactic core, an area that is difficult to study because of interstellar dust. These observations will shed light on the nature of the supermassive black hole Sagittarius A, the stars near it, and the thick galactic bulge that surrounds them. When we think of a planet surrounded by cosmic halos, we usually think of Saturn. Saturn's entire personality, one could argue, is centered on those magnificent rings, and rightly so. They're solid, recognizable, even exquisite. But if you didn't already know, Neptune has rings as well. They're just a lot more delicate and thus extremely difficult to see without powerful telescopes. In fact, the planet is 30 times further away from the Sun than Earth and appears to ordinary stargazing instruments as nothing more than a faint speck of light. Despite our inability to admire Neptune's delicate hoops from here, scientists were able to catch a wonderful glimpse of them girding the azure realm in 1989 thanks to NASA's travelling probe Voyager. And now, the agency's equally exceptional James Webb Space Telescope has provided us with round two. It has been 3 decades since we last saw these faint, dusty rings, and this is the first time we've seen them in infrared. Heidi Hamel, Neptune system expert and interdisciplinary scientist for the JWST, said in a statement, "Webb's extremely stable and precise image quality permits these very faint rings to be detected so close to Neptune. As if that weren't enough, this new image shows Neptune emitting a delicate lavender light via the JWST's near-infrared lens, against a backdrop of galaxies captured by the same piece of cutting-edge space technology. It's unmistakable confirmation that the JWST is far too sensitive to detect what we would call blank space. Every time it looks into the abyss, this machine is strong enough to unintentionally lock a chest of riches. The bright luminosity shown in the JWST's image of Neptune is only possible due to the telescope's infrared capabilities. This image depicts the invisible infrared wavelengths emitted by the gaseous planet. We aren't looking at the sort of visible wavelengths we're used to, ones that show us colour like the kind the Hubble Space Telescope works with, for instance. Neptune still has its signature blue tints stemming from elements on the planet, such as the methane gas, but the JWST can't show them to us. That's not what it was built to do. In fact, the methane gas is so strongly absorbing that the planet is quite dark at Webb wavelengths, the European Space Agency said in a press release. Except where high-altitude clouds are present, such methane ice clouds are prominent as bright streaks and spots, which reflect sunlight before it is absorbed by methane gas. The researchers also noticed a bright ring around Neptune's equator, which they interpret as evidence of the winds and storms that drive Neptune's atmosphere. The atmosphere descends and warms at the equator, and thus glows at infrared wavelengths more than the surrounding cooler gases, NASA said. The agency also reports finding intriguing brightness near the North Pole and more evidence of a vortex at the South Pole. Lastly, the JWST spotted 7 of Neptune's 14 moons, including Galatea, Naiad, Thalassa, Despina, Proteus, Larissa, and Triton. Triton's strange backward orbit is revealed by the JWST's unique 6-spiked glare, giving scientists hope that the JWST can assist deciphering the bizarre situation. Let's hear your thoughts now in the comments section below.